With Elon at the helm of SpaceX, you can expect there will be shocking developments regularly. The man has been at the forefront of technological innovations for almost 2 decades now. In fact, the billionaire is spearheading a push for a greater focus on space exploration. His commitment to the cause has led to some significant discoveries. We're about to take a look at the co-founding science underlying none other than our own sun. While it seems NASA generally has a focus on far-off galaxies, they may have found something incredible a little closer to home: our sun. The sun is roughly 93 million miles away from Earth, and temperatures are as hot as 5,500 degrees Celsius, although we have distance and our own ozone layer which protects us from its heat. You need some serious advances to tackle the challenge of visiting this giant ball of plasma. But happily for us, NASA was more than up to the task. The Parker Solar Probe is a NASA space probe launched in 2018 with the mission of making observations of the outer corona of the Sun. Elon Musk has taken a keen interest in the Parker Probe research as the Sun supports our solar system's planets and all life as we know it. So the question is, what did the Parker Probe just learn about the Sun? And how does this affect you? We all know that the Sun is massive, but the question is, exactly how massive is it? Let's put it this way. If it was just on the basis of size, 109 Earths could be lined up over the face of the Sun, or 1 million Earths could fit inside of the Sun. It's pretty big is all we're saying. What about the mass? The Sun, unlike the Earth, has no solid mass, but it is extremely dense, with a mass of 1.989 times 10 raised to the power of 30 kilograms. These figures can easily confuse even the smartest person in the room, so just to put things into perspective, again, the Sun accounts for around 98.2% of the weight of the entire solar system. Now you have to take a look at our favorite ball of fire's temperature. According to NASA, the Sun's surface temperature is roughly 10,000 degrees Fahrenheit, or 5,500 degrees Celsius, while its core temperature is above 27 million degrees Fahrenheit, or 15 million degrees Celsius. That's hotter than your average barbecue and then some. Now the question that we must ask is, how can the Sun generate such vast amounts of energy? Well, the answer lies in nuclear fusion. The Sun has a plentiful supply of hydrogen, which is compressed and fused to produce helium. Talking more about the Sun's structure, the corona is the outermost layer and the furthest from the core. What's strange is that this layer is hotter than the other 2 layers. This phenomenon is something that scientists have pondered for many years, and now the Parker Probe is helping shed some light on it. To face the immense temperature, the probe has a carbon fiber heat shield that will protect the spaceship and its vulnerable equipment from the Sun's intense heat as it orbits our nearest star. The probe will reach 3.8 million miles above the Sun's surface, and as it approaches, the Sun's tremendous gravity will accelerate to a staggering 430,000 miles per hour. This will make the Parker Probe the fastest a man-made object has ever traveled. Parker is the first man-made object to experience the Sun's atmosphere. It accomplished this in April of last year by entering the star's heated upper atmosphere, which has a temperature of roughly 2 million degrees Fahrenheit. The probe used an onboard instrument known as the Solar Probe Cup to sample particles and magnetic fields as it flew through the Sun's upper atmosphere, or corona. This is the flyby that would help scientists unravel critical information about the Sun's influence on the solar system. The probe detected nuclear fusion in the Sun's core, which generates vast quantities of energy that radiates outward to the Sun's surface atmosphere and beyond. Energy moves from the center to the radioactive zone, where it bounces around for up to 1 million years before moving up to the convective zone in the upper layer of the Sun's interior, where large bubbles of hot plasma form a soup of ions as the temperature drops below 3.5 million degrees Fahrenheit, or 2 million degrees Celsius. These discoveries are just the tip of the iceberg, as over the lifespan of the probe, it is due to move roughly 3.8 million miles away from the Sun's surface before burning up into stardust. The discoveries are proving to be incredibly valuable to our understanding of the Sun's power and predicting what Earth's atmosphere may encounter in the future. With so much on the horizon with Parker, it's no surprise that the world is looking with bated breath at what new mysteries will be unveiled next. Click one of the 4 videos on the screen right now.